Hello everyone, I'm Suhasini. Welcome back to my channel Learn with Suhasini Shinde. And like prior to the last class or the last video, we have completed a very first chapter, right? You get a series video lectures of 10 videos for the first chapter, that is electric charges and fields, right? And if at all you want to learn the very first chapter, you can go through and check the playlist and you can learn the entire chapter. I assure you that you will be understanding it very easily, right? And in the very last class, we have started with the very second chapter, that is electrostatic potential and capacitance. In electrostatic potential and capacitance, we have completed two derivations, right? We have found out in the very first class, we understood that what was electric potential, right? And then later on, we have understood what was the potential difference. And then we moved on to the derivation of electric potential at some particular point due to a point charge. Then we move on to finding out what was the electric potential at some particular point due to system of charges, right? These were the two derivations that were explained in the very last class, right? Now, immediately after that, the next derivation is about electric potential due to a dipole, right? And this derivation is seen into this particular class. In the very last class, I have explained you about the electric potential. Electric potential is defined as the work done in bringing a charge from the infinite distance to a point against the electric field, right? The amount of the work done in bringing that particular charge is called as electric potential, right? Now, what is dipole? In the very last classes of mine, in the first chapter, that is electric charges and fields, I have defined you what was dipole. Dipole are the two equal and opposite charges with the same magnitude but with the opposite signs, right? What does that mean? You have two charges, right, equal in magnitude. One is positive and one is negative. Equal in magnitude in the sense, say for example 3 coulomb, right? 4 coulomb, whatever the magnitude that a charge hold is equal, right? But they are opposite in their signs, right? With a very small distance between them, which is called as 2a. 2a will be this distance between that dipole, right? Now this particular arrangement give rise to a dipole, right? If at all, say for example, you have a positive and negative, both are positive or both are negative with the same magnitude, say 3 coulomb or 10 coulomb, right? This is not dipole, right? Dipole means you should have two charges equal in magnitude but opposite in their polarities, right? With a very small distance in between them. That only give rise to dipole. Only this creates a dipole, not these two, right? In this particular expression, that is derivation, what we will find out is, we have some point, right? We have dipoles. It is positive charge, negative charge with a distance between them, that is a very small distance between them, that is 2a. Actually, the point which is considered, that is the point which is considered from this dipole, is so far that the distance is very small. When considered from the center of this particular dipole, the point is located at the distance of r. What is the distance between the point and the dipole? It is at the distance r from the center, right? Now this distance r is so large that it is so large when compared to the distance between the dipole. For what it means, r is very greater than 2a distance. Did you get what this mean, right? The point that is held at some particular place, right, with respect to the dipole is so large that the distance between the two dipole is very small. What is the distance between the two dipole? It is 2a, right? 2a is so small than the distance between that particular point, right? Here what you find is, you will find out what is the electric potential at this particular point due to the dipole. In the very last classes, we had a point and then we have found out what was the electric potential at that particular point, right? We also had a two derivation, one because of the point charge and another because of the system of the charges, right? So whenever you have so many charges in a system, then how do you find out potential, that is electric potential at some point? What you do, you take the potential individually and you add algebraic sum of all the potentials at that particular point, right? In the similar fashion, this is a system. In this system, what type of the charges or how many charges you have? You have two type of the charges, one is negative and one is positive, and you have two charges, that is A at a point A and at a point B, right? Now what you do here is you will find out what is the electric potential at this particular point due to the charge minus Q, and then separately you will find out what is the electric potential at a point P due to positive Q. Then you get two potentials here due to positive Q and due to negative Q. Then you add algebraic sum of both the potentials at that particular point. Is this clear, right? Now how do you write? First you write down what is the potential, right? Now the total potential is given by, the net potential can be described as V1 plus V2, right? Okay, did you follow up to this particular point? A net potential at this particular point P due to dipole will be the algebraic addition of both the electropotentials. Okay, now this particular vector here, this particular line is called as position vector, right? Position vector, right? Why it is called as position vector? Why? Because the line which starts from the origin and shows the position of some particular point. This line is showing what? It is showing the position of this particular point P, right? So this particular line is called as position vector. And you have another vector here. It is a dipole moment. The strength of the dipole is given by the dipole moment. In the very last classes we have explained about and we have seen about what is dipole moment, right? The strength of any electric dipole is given by the dipole moment, and the direction of the dipole movement will always be from negative to positive, and hence it is shown like this, right? So we have two vectors now. One is a dipole moment, right? Another is a position vector, right? There is an angle formed between the position vector and the dipole which is called as theta, right? Is this clear up to this particular point? Right? Now there is an angle that is made theta, that is this theta is with respect to the position vector and the dipole moment. Now you want to know what is the electric potential at this particular point due to minus Q and what is the potential at this particular point due to plus Q, right? Now what is the distance between minus Q? You join a line from minus Q to this particular point and say it as R1, right? Now you have another line that joins positive Q to P, that is R2. The distance between minus Q to P is R1 and plus Q to P is R2, right? Now you will find a potential, that is electrostatic potential, one by one individually, and then you add it, right? Now let us consider V1. What is V1? In the very last classes, we have discussed what was the electric potential due to a point charge, right? You write the same thing, 1 divided by 4 pi epsilon naught, right? What was the charge? It is minus Q. So minus Q is taken, divided by what is the distance between these two, that is A and P? It is R1, right? This is the potential at that particular point P due to a charge minus Q, right? On the similar lines, you will be having for V2 also, right? That is the potential at this particular point due to plus Q. So what it is? 1 divided by 4 pi epsilon naught positive Q divided by R2. Now what you do? You add both the V1 and V2 to get a net potential at this particular point P. So how you do it? V net will be equal to V1 plus V2. So V1 is what? 1 divided by 4 pi epsilon naught minus Q divided by R1, and here it is plus 1 divided by 4 pi epsilon plus Q divided by R2, right? You take Q divided by 4 pi epsilon outside, right? It is 1 by R2 minus 1 by R1, right? I have just shifted this term. Why? Because this is positive and this is negative. This I have taken here and this I have taken here. So it is 1 by R2 minus 1 by R1. So take the LCM. What you get? Q divided by 4 pi epsilon naught, right? That is R1 minus R2 divided by R1 R2. This is what? The net potential at this particular point P due to a dipole of positive and negative charge. Is this clear up to this point? Okay, hope it is clear up to this particular point. How did we get this potential equation? That is Q divided by 4 pi epsilon R1 minus R2, R1, R2. Now this is the potential at this particular point P due to the electric dipole, right? Now actually, if you could remember, I have said you the distance from this origin, that is this O is what? It is a midpoint of this dipole, right? And this R is a distance vector, this R is a position vector of this particular point P. Now this R is so large when compared to the 2A. The diagram should be negative, positive, the distance is 2A, right? And it is placed at this point, right? Why? Because this is R, which is very much greater than 2A, right? Actually the diagram should be like this for the dipole, right? We are finding out what is the electrostatic potential at this particular point, but this doesn't make you understand proper, so I have drew it like this, right? Actually the diagram is like this. According to the geometry, now this angle are so small, the angle that is made at this particular point with respect to the two charges is very small. Whenever you have two lines and a very small angle that is made in between them, right, you always drop a perpendicular such that the two lines will be equal. Say for example, now compared to this line, that is a central line, this line is small, right? What you do is you drop a perpendicular at this particular point, right? When you drop a perpendicular, this is 90 degree. When you drop a perpendicular line on this line, that is AP, right, such that the R1 and R2 distance are equal. Now these two lines are equal in nature, that is equal in their length. And the remaining line here, what is the here, right? It is a difference of R1 and R2. What is this length now? It is the difference of both the lines, R1 and R2. Now this was R1, right? The whole line was R1 and this was R2. R1 minus R2 will be this particular distance, right? So what you do according to the geometry, whenever you have a very small angles between the two lines, what you do is you drop a perpendicular such that the two lines become equal in their length, right? And the remaining line will be the difference of that two lengths, right? This is R1, this is R2, and the remaining length is R1 minus R2, right? Now you find out what is the cos theta for the triangle QAB, right? Cos theta can be represented in two forms. We also know what is this distance, that is R1 minus R2. We also know this distance, that is 2A. In these two terms, we can represent the cos theta as adjacent divided by hypotenuse, right? What is adjacent? Adjacent is R1 minus R2, that is R1 minus R2, right? What is adjacent? Adjacent height is 2A, right? And hence therefore cos theta is equal to R1 minus R2 2A, right? Therefore R1 and R2 can be written in terms of R1 minus R2 can be written in terms of 2A cos theta, right? And what is the distance? That is R1 and R2 are both similar, that is the both has the same length, so you can write R1 is and R2 are both so similar that you can write R1 square or R2 square, right? So substituting these values, right, in the equation of electric potential, we get, substitute, instead of writing R1 minus R2, you substitute 2A cos theta. Instead of writing R1 R2, you substitute R square. Now this R1, it need not be either R1 or either R2. It is just R square, right? Now substitute the values of this. That is V is equal to Q divided by 4 pi epsilon naught, right? R1, R2 is what? R1 minus R2 is 2A cos theta divided by, what is R1, R2? It is R square, right? Now if you could remember, what is the dipole moment? How the dipole moment is being defined? A dipole moment is product of the charge and the distance between the dipole, that is Q and 2A forms the dipole. What is the formula for the dipole? Dipole is the product of the charge and the distance between them. right? You have here Q2A. Instead of writing Q2A, you can substitute what dipole moment is. So what you get? V is equal to dipole moment, right? Cos theta divided by 4 pi epsilon r square, right? So this is the final electrostatic potential at a point which is located very far from the dipoles. This is the final expression for the electrostatic potential at this particular point P, right? Did you follow all these things, right? And then, now this particular point, if this point lie exactly on this axis, say for example this is a dipole, negative and positive, and you want to find out what is the potential at this particular point, right? You want to find out the P is lying on the axis. Now what is the theta that is made, or the angle that is made between the position vector and the dipole moment? It will be 0, right? So whenever cos theta is 0, right, you get maximum potential at that particular point. Why? Because cos 0 will be equal to 1. The very next case is when the point lie on the equatorial line. What do you mean by equatorial line? If this is the triangle, right, the line that is drawn at the center, and if the point is anywhere on this particular equatorial line that makes an angle 90 degree, right, then the potential difference at that particular point will be 0. Why? Because cos 90 is equal to 0. Therefore, substituting in the value P is equal to P cos 90 degree divided by 4 pi epsilon naught r square. This becomes 0. The entire term becomes 0, right? Whenever a point lie on the equatorial line, that is on equatorial line, making an angle of 90 degree, right, then the potential at that particular point will be 0. What we have got? V is equal to dipole moment cos theta divided by 4 pi epsilon naught r square, right? We have two conditions. If theta is equal to 0 degrees or theta is equal to 180 degree, right? What will be the potential? What will be the potential if theta is equal to 0? If theta is equal to 0, right, then you get theta is equal to 0 is what value? It is 1. So P into 1 divided by 4 pi epsilon naught r square, right? You get maximum potential at theta is equal to 0 and theta is equal to 180 degree, right? So the potential at this particular point may be plus or minus 4 pi epsilon naught r square. Now this is the potential, maximum potential. The potential that is generated due to a positive charge will be positive potential. The potential generated due to negative charge will be negative potential, right? You should always remember that the potential can be positive, can be negative, depending on what amount or what type of the charge that you have taken, right? Now this indication of whether it is positive or negative in this electrostatic potential is very important, right? You should always mention whenever you say electrostatic potential. Now that particular potential is because of two charges. Either it could be because of positive charge or either it could be because of negative charge. If at all the potential generated is because of the positive charge, then it will be positive potential. If the potential generated is because of the negative, then it will be negative potential, right? So whenever the angle theta is equal to 0 or 180 degree, when is the angle theta 0 or 180 degree? When the point lie on this axis, when the point that we are considering on this particular axis line, that is A, B. If you want to find out what is the potential on this axis of the dipole, that is theta is equal to 0 degree or theta is equal to 180 degree, then you have maximum amount of the electric potential, right? Now, in the second case, if theta is equal to 90 degree, what does this mean? What does this case says? Theta is equal to 90 means this theta should be 90. The point should be on the equatorial line. How do you represent it? Say for example, now this is the dipole, negative, positive, right? Now this is the equatorial line making an angle 90 degree. Any point on this particular equatorial line making an angle of 90 degree will be having 0 potential. Why? Because when you substitute V is equal to dipole moment cos theta 4 pi epsilon naught r square, when cos theta is equal to 90 degree, it is the indication of value 0. When cos theta is equal to 90 degree, what cos 90 is? It is 0, and hence the whole value becomes 0. Then what does it mean? You do not find any potential when a point is placed on the equatorial line. And hence you have these two conditions, when theta is equal to 0 and 180, right? And when theta is equal to 90 degree. Did you follow up to this particular point? Okay, this was all about today's class, right? Hope you have understood all the explanation that is done. In the very next class, we'll be dealing with the equipotential surfaces. Hope you have understood all the things very properly, right? You please do subscribe to my channel. If any suggestions, you please drop your message into a comment box, right? And do share my link with your friends and families. Keep supporting. Thank you so much.